Welcome back. In this, we will continue the index properties and we are at unit weight. So, I will discuss the very last method in this section, which is sand replacement method, okay, or sand cone method. First of all, we will look at what is this arrangement, how this equipment is. Look, there is an container or a cylindrical container. Here there is a shutter, okay, this is the shutter, and beneath this there is a cylindrical cone attached to this. Sorry, how could be a cone be cylindrical? It is a conical shape. This is the equipment which we will using here, okay. So this is cylindrical container, this is shutter, conical pouring, cylindrical pouring, so conical pouring cone, okay. This is pouring cone. What all this term means, we will understand it very in detail. Sorry for this, okay. As you have seen, this is the setup, this is the arrangement. So as I have said in last class that this method is suitable, this method is suitable for cohesion less type of soil, that is maybe sand, gravel, dry clay, all those soil for which the previous three methods are not suitable. This method can be applied on those soil to determine their unit weight, okay. So this is the idea of this method, but no, sorry, we have not yet discussed the idea. So where this method is used, this method is a field method, okay. Field method generally used in highway constructions, okay. This method, this this method is performed under two stages, okay. In first stage we calculate unit weight of a standard sand sample, and in second stage we compute the unit weight of required soil specimen. Okay, so let us move towards the first stage computation. Stage 1. What we do in stage 1 is we have to compute the unit weight for a standard sand. And what is the standard sand sample? Let a sieve, two sieves are placed. This is 600 micron and this is 300 micron. What is micron? 1 micron equals 10 to the power minus 3 mm, approximately 10 to minus 6 meter. Okay, this is 1 micron. So let it two sieves are placed of 600 micron and 300 micron. Now pour the sand sample over this. Okay, so there will be two cases. Some sand will retain over this and some sand will retain over this, and some will pass through this. Some will pass through this. This is sand poured over sieve. This is retained. This is also retained. This is retained over 300 micron. Retained, and this is passed through 300 micron. That is finer than 300 micron. That is finer than 300 micron. But what is the standard sand for this experiment? Is this soil which is in this range, in between 300 to 600 micron. That is, this sand sample which is retained over 300 micron sieve will be considered as standard sand sample. Okay, so you have got the standard sand sample. Now what we have to do is, do you remember the setup? The setup was the cylindrical jar or the cylindrical container. There was the shutter, and the conical pouring cone. Okay, the conical pouring cone. Now what we do is we place the sand sample, standard sand, in the cylindrical container. Let this weight be W1. Okay, what is W1? Weight of standard sand in the cylindrical container. This is W1. Now after having this weight, what we do is we remove this shutter, we open this shutter such that the the sand in this, from this cylindrical container fills the conical pouring cone, conical pouring space. Okay, let the, this is the sand filled here. Okay, let this weight be W2. So what will happen in above? The level of sand will fall, and what it will be, let this will be W2. The level of sand will fall down now. Now after having this is what is W2? Volume of sand filling conical pouring cone, conical pouring space, conical pouring volume. Okay, now what we do in final stage, that we placed a calibrated container of known volume beneath this pouring cone. Okay, we know its volume, VC, let V calibrated, known, calibrated container of known volume. Now sand is allowed to fill into this container. The sand is filled here. So let after filling the calibrated container, the level of sand which finally remained in cylindrical portion be W3. So what is weight of sand filling the calibrated container? It will be W1 minus W2 minus W3. Okay, so unit weight of standard sand will be weight over volume equal to VC, volume of calibrated container, which equals W1 minus W2 minus W3 divided over VC. This is gamma standard sand. Now having this, let us move towards the second stage of this experiment. Second stage. In second stage, what we do is we decide the location from where the soil is to be excavated, that is for which we have to determine the unit weight. Let this be the location. Okay, here there is excavations made. Okay, soil is being excavated. Okay, soil is excavated from the site. Let this be the excavated volume. So, and its weight is W soil. W soil excavated volume. Excavated volume, excavated soil, actually not volume, sorry, excavated soil, and its weight is W soil. Now what we left here on site, we left with the empty space. Okay, we left with empty space. Now what we do is we bring that setup over here, that is the cylindrical container and the conical pouring cone. Okay, so let volume of sand in cylindrical container, weight of sand will be W1. After allowing, let it the after filling the pouring cone, let the weight here remain is W4. Let it be at this level. Now from this level, again this sand is poured into the empty space, that is the space from where the soil is being excavated, and it is completely leveled, the volume is filled. So let the final, let the final level which remained in the cylindrical container be W4. So what is the weight of sand filling the excavated volume? It is W1 minus W2 minus W4. Yes or not? Now since we having weight, hence volume of excavated space we can get easily. Why? We have the density of this sand which we have calculated in first stage. Okay, volume of excavated space will be W1, weight of sand in excavated space, divided over density gamma sand of standard sand which we have calculated earlier only. Since we have got volume of excavated space, hence unit weight of required soil specimen will be weight of soil which we have measured already, divided over volume of excavated space which we have calculated in second stage, W2 minus W4 over gamma sand, and we already computed gamma sand in first stage. So this is how we perform the sand replacement method or cylindrical cone method or cylinder cone method. Hence now in all this method we have noticed one thing, that volume of this solid or this soil is computed in different method by different process, but the speciality of this method, speciality of this method is that it is applicable for any type of soil. For any type of soil you can perform this method over any type of soil. Okay, generally used, but generally used in field construction works, example highway developments or runway developments. Okay, These are the sites where we regularly use the sand replacement method. Well, now here we finish the unit weight index property completely. We have seen all the four methods. The if I will recall, the first method which I have seen is core Kathar method. Second method was the water replacement method, and the third method was the submerged mass density method, and this is the fourth one which we have discussed now. Now the very next index property is particle size distribution. This index property is very important because it will build up your basic idea for soil classification. Okay, and in this method, in this index property, we will discuss hydrometer and pipette method, which are the most toughest part of this soil mechanics subject. If you understand this hydrometer and pipette, you will understand all other thing. Well, thank you.